Well, yeah, I thank you all for logging on. Conscious that this is quite an unusual situation and it's first thing in the morning. So thank you everybody that's paused getting the kids dressed and getting the cats fed, etc. So I want to talk about carbon today, and not really about climate change per se, but let's just see if we can recap on some stuff that happened last year. So in 2019, the media, the mass media was generally kind of prepping for 2020 to be the year of climate action. So some of the stuff that happened, the Fridays for Future movement, Greta Thunberg, Extinction Rebellion in the UK, governments declaring climate emergencies all over the place. And these were all underlined by obviously the tragic wildfires in Australia, the huge loss of life, human and wildlife in Australia, and other bits and pieces. So there was record floods in Venice. So Venice 2019 looks very different to Venice in 2020 now, it has been a year of climate action in a way. So we've seen around the world, because of COVID-19, we've seen some quite profound changes in the environment. We've seen air quality improvements in cities. We've seen water quality improvements in Venice, and there has been a reduction in greenhouse gas emissions because there's less travel. We don't know how much quite yet, but it'd be interesting to see at the end of the year how significant they are. But there's a general consent, or this at least seems to be a general consensus, at least in the UK media, that these environmental improvements are positive. So what happens after startup? What happens when the economies have to start going again? Well, let's be honest, nobody's been frantically busy building wind turbines or solar panels during lockdown. So when we restart, we're going to be restarting using the technology that we had before. What I like to believe that there won't be the same level of travel, etc., that there was before, because we've been able to use things like Zoom, because we've got better at using digital technology for stuff like this. We don't have to commute long distances to work sometimes every day. So I think there'll be a reluctance to go back to the previous. Now, if we look at the potential for recovery, or we look towards the recovery, a lot of you might have seen a diagram like this before. So we know for years, the whole point of this conference is that sustainable minerals have been a pressure area for mining for years. So consumers looking to buy sustainable products have been putting pressure onto manufacturers, which have in turn been putting pressure onto mining. Financiers from the other direction have been putting pressure onto mining, because things like the Church of England pension fund that was mentioned earlier, they don't want to have their pensions invested in irresponsible companies. So when they look for investment opportunities, they're going to be looking for ethical opportunities for companies that are being more ethical in their business models. So in a cash careful recovery, there's two things that could potentially happen. Either there won't necessarily be an increase in spending because everybody will be conserving all their cash, or what I like to believe will happen is there'll be an improved emphasis, or an improved focus, or an increased focus on those products that are sustainable. And Grant gave a great talk earlier on being able to actually prove that these products are sustainable throughout the supply chain. So one of the places that you can go if you want to know whether the company that you're investing in, or whether the product that you're buying eventually sort of comes out of the ground in a sustainable way, or in a way that sort of is more ethical, is to go to the Carbon Disclosure Project. So I'm sure a lot of people have seen this before, but the CDC has been operating for some years now, and they've been ranking businesses and industry for some years on, among other things, their climate change performance. Now, a large part of their matrix for allocating a score like that is how well a company how well the governance is arranged in a company. But in order to get onto the list in the first place, you need to come up with a number. So really what I want to talk about today is the calculation tools that are available and how to come up with this greenhouse gas number in order to then plug into the rest of the system. So there are there's quite a few methodologies. There's those that are sort of almost choice methodologies. So on the left of the screen, there's the Carbon Trust Calculator and the ISO family of standards. In the middle, we've got things that are almost expectations on business. So the ICMM have the Transition Pathway Initiative. If you're a steel company, the World Steel have a scope for calculating your greenhouse gas emissions. So if you're a member of these institutions, it's expected that you apply these. And then there's the requirement side. So law, there's lots of emissions trading schemes, taxation schemes, quota schemes. That if you qualify as a company, then you have to then implement these requirements and you have to calculate in a certain way. Now, there's other requirements that come from finances. So the IFC, for example, larger companies that it funds have to disclose based on the greenhouse gas protocol, which is at the bottom there. So the greenhouse gas protocol is a sort of big open-ended tool that can be applied to almost any company, but it is required sort of by the IFC and the EBRD for some of its clients. Now, I want to just touch on some common elements of these. So this kind of turns into a bit of a training presentation, I guess, for anybody that's looking to start putting together one of these inventories. So common elements, in terms of scopes, we all know about scope 1, 2, and 3 emissions. Scope 1 is direct emissions, 2 is indirect, and scope 3 is stuff that happens sort of further down your supply chain. The only real common element is not only scope 1 stuff, but stationary scope 1 stuff. So the emissions trading scheme in Europe, for example, doesn't care about mobile equipment. If you've got a tank of diesel on your site, half of it is used by a generator, the other half is used by a forklift truck. It doesn't care about the forklift truck. You only need to know what's fed into the generator. So that's the only real common element in terms of scope between all these. Scope 2 and 3 are very, very important, especially for working out supply chain impact. So for consumers and customers, they are very important. But for mining companies, often right at the bottom of the supply chain, where stuff gets extracted from the ground to begin with, you have to nail scope 1, definitely. And you have to be aware of your scope 2 emissions as well. So the stuff that you feed into these calculations, activity data. So you need to know how much of stuff you use. Liters of fuel, tons of coal, normalized cubic meters of natural gas. Gas is one of those things that you need to make sure that you normalize to temperature and pressure. So as long as you've got normalized gas, you can convert between the different normalization metrics. CO2 going up a stack. I don't like stack emission technologies because they can sort of cross-read, and also in order to get the best use out of them, you have to make sure that you calibrate them correctly, and your QA and QC has to be particularly strong. Kilograms of refrigerant gas, right? Refrigerant gas, it feels like I've got a fridge on or air conditioning unit on at the moment because it's so cold, but refrigerant gas is particularly potent as a greenhouse gas because it's used for insulation properties. So 1 kilogram of refrigerant gas can be up to 10,000 times as powerful as CO2. So I'll come to some equivalencies in a second. Electricity, you need megajoules of steam energy. Activity data is normally good quality because this stuff is expensive. Okay, so your accountants would have been fretting about this already, so it's easily findable. Then activity data needs to be multiplied by some kind of factors, and so everything on in these things, NCV, EF, OXF on the right-hand side of the screen, they're all factors. So these factors are where the kind of the standards and the protocols come in. Global warming potential, as I mentioned, refrigerant gases are particularly potent. Everything has to be equated to CO2. So the CO2 equivalency is an important factor that sometimes you have to add into your calculation. A lot of the legislative frameworks give you factors because they're government sort of produced, so they expect you to use a specific factor, which often includes global warming potential. So that solves a bit of a problem there. Emission factors, sometimes you have to work out your own emission factors, but they're normally per volume or per energy. So the amount of CO2 produced per ton of diesel, or the amount of CO2 produced per megajoule of energy. So net calorific value is a factor that then allows you to use an energy-based emission factor. Oxidation factors, I don't necessarily worry too much about oxidation factors because often they're one, but there are instances where an oxidation factor comes in useful, and it's important to apply it where it's applicable. Sometimes your direct emissions, your scope 1 emissions, aren't necessarily what you burn on site. If you're a cement manufacturer, you put limestone in, you heat limestone up, and then you get calcium oxide at the end, and you mix it with some other things to produce cement. You're not burning the limestone, you're just heating it up to dry the CO2 off. So in instances where you can't necessarily measure your fuel going in, or it's not a fuel that you're looking at, as long as you know how much of the stuff goes in, your activity data, and you know how much carbon is in that activity data, or in that material, you can do the same thing when on the stuff that comes out, and the difference in carbon, multiply that by easy number 3.664, and it tells you how much CO2 you've emitted in the process. Okay. Finally, some common elements, right? It's a well-discussed subject at this conference, but governance. You have to give confidence to everybody down the supply chain that the number that you've come up with, the CO2 value that you've come up with, is reliable. It's based on something tangible. So uncertainty, you have to understand the calibration, or you have to make sure that the metering that you're using is calibrated, because vast differences in uncertainty or large uncertainty numbers reduces confidence in the value that you produce. More often than not, you have to have policies, procedures, things like corrective action systems in order to make sure that, if something goes high, that you can bring it back down and you understand the root cause of a problem. A ton is a ton. A ton is a ton because sometimes the ton has a value. So in Europe, a ton is worth about 25 euros. In Kazakhstan, the scheme there is worth about 500 tenge, which is around 2 pence, I think. But it's going up. In South Africa, a ton, there's a tax of I can't remember. It's quite a bit of rand per ton of greenhouse gas. You have to be certain that that ton is equivalent in a power station to a cement factory down the road. And then reporting to regulators, financiers, and customers. Now, in some of the financial requirements and some of the financial systems, you also then need to have verification. The Greenhouse Gas Protocol also recommends verification, but if in the financial systems you don't have it, you can't trade, and you can't make your money, and you can't carry out any transactions at all. So yeah, if there is, we have done a couple of studies in the company. You can go on the website and find this. If you do click on that, though, just be aware that the picture of me in there is post COVID beard. So this is what it looked like now. Right, so that's the end of the presentation. So I'll open it up to questions if we have time, Sarah.
Yeah, fantastic. Thank you very, very much for that, Chris, and giving us a really quick but comprehensive overview with regards to complexities of trying to calculate all of that carbon as a whole. It's brilliant. So just one very quick question, just in the interests of time. Do you find that sometimes there is misunderstanding when people are talking about carbon, especially with regards to industries such as coal mining? Because you've got the carbon footprint at those different levels, obviously, with regards to the actual activities that are being undertaken by the company. And then also because the fact of what they're producing is carbon-based as well. I don't know if you want to make any comments to that.
Yeah, well, it's important to, with mines in particular, and coal mines is a good example, that a coal mine really when you look at the data, it can have a very, very small carbon footprint, because all they're doing is moving a bit, materials around, and really that, compared to the actual combustion of that coal in the power station down the road, is a very small proportion. So it is sometimes the media attention and the NGO attention is sometimes disproportionately targeted at coal mines, whereas actually, the root cause is that, the infrastructure of the country is based on, thermal coal. So it's the energy companies that have a little bit, the opportunity to diversify into renewables. It's there where it's that the ire should be directed at, really, not necessarily the coal mines. But it's also important to make a difference between thermal coal and metallurgical coal. Met coal, is to make steel, you need met coal from ore, or you need to use met coal to make iron from the iron ore. There is no other viable way to do it at the moment. So, to target the wrong mine if you're a protest group, is sometimes it's a bit I find this a bit misdirected, but it does put pressure to diversify and to move away from these processes. So sometimes perhaps it's good.
Brilliant. So with that, thank you very, very much, Chris. I hope your bedroom does warm up at some point in time. So massive round of applause from those of us on the other side of our muted microphones.